Hello everyone, welcome back to the channel. And yes, after a long time, I will soon let you know why it was a long time. But in this module today, we will learn a solved example. We will learn a sum based on 3-digit number. It's a very beautiful sum, so pay attention. And before that, do not forget to subscribe the channel. A 3-digit number is equal to 17 times the sum of the digits. If the digits are reversed, the new number is 198 more than the old number. Also, the sum of the extreme digits is less than the middle digit by unity. Find the original number. A very important sum. Already asked around 2013 or 14. I do not remember the exact year, but it is asked in boards already, in state board of Maharashtra. So very important terms. So before we start with the sum, actually, let us clear on few basics. Now, when I talk about a 3-digit number, so it talks about digits, right? In mathematics, there are 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So understand, using this 10 digits, we form infinite numbers. So there are 10 digits. Now let us take an example of 3-digit number, since this sum is based on 3-digit number. Now using this 353, now the question is, how do we get the digits? Here are 3, 5 and 3. Here I can say this is in hundreds place, 3. This 5 is in tens place, and this 3 is in units place, or we can also say it is in ones place. Now the digits here are 3, 5 and 3. Understand, the digits are 3, 5 and 3, and the number is 353. Now using these digits 3, 5 and 3, how do we get 353? Is we multiply the digit in the hundreds place by 100. We multiply the digit in the tens place by 10, and we multiply the digits in the ones place by 1, and we add all of them. Now try adding them. 300 plus 50 plus 3 into 1 will be 3. That will be 353. So this is a very important concept we need to understand even before we go to the sum. The digit in the hundreds place is multiplied by 100. The digit in the tens place is multiplied by 10. The digit in the ones place or units place is multiplied by 1. And when we add them, we get the number. Let us do it for one more number. So you can try it out. It would be 4 into 100 plus 5 into 10 plus 9 into 1. You can check it out. This would be 400 plus 50 plus 9, and that is going to be 459. Now, keeping this in mind, let us go ahead. Now I will look at this question, and we need to remember that the digit in the hundreds place will be multiplied by 100, tens place will be multiplied by 10, and units place or ones place will be multiplied by 1. So before we start with the sum, before we try to solve the sum, we need to define what is the digit in the tens place, units place, and hundreds place. Hundreds place, tens place, and units place. We can take it x, y, and z, but since we do not have 3-digit equations in our sum, it would not be appropriate. I'm not telling it would be wrong. You will get the answer though, but we will try and avoid taking x, y, and z. Okay, so I'll read the entire sum and I'll see where do I get the information from. The 3-digit number is equal to 17 times the sum of the digits. It will form an equation. If the digits are reversed, yes, we know that in 2-digit number we have seen the number is 198 more than the old number. So once again, the digits, no information given about the digits. Also, the sum of the extreme digits is less than the digit in the middle term by unity. Now this is the most important statement. Now we are going to start using the second last statement in the sum to solve the sum. Now when I say hundreds, tens, and hundreds, tens, and units, now it clearly says sum of the digit of the extreme. So these two are extreme, the first and the last, and this is the middle term. So definitely I will take this as x and this is y, because sum of the extreme digits, so x plus y. So what will be the first statement would be, let the digit at the hundreds place be x and digit at the units place be y. Now how do I get the digits in the middle place, that is tens place? Now look at this statement once again. The sum of the extreme digits, that means x plus y, okay, is less than the middle digit, that is tens place ka digit, which is called as middle digit. Right now I'll keep it as t, by unity. Now unit, the word unit in mathematics means one. So whenever it says it increased by unity, or it is decreased by unity, or it is less by unity, it means ones. So it will be less by 1. So can I say x plus y minus 1, it shifts this side, it's plus 1. This is my digit at the tens place. Okay, so I can clearly say, therefore, now digit at the tens place, it cannot be units place, it has to be tens place, would be x plus y plus 1. Now this is the most important thing here. Okay, now students, since we have defined all the digits, hundreds place, tens place, and units place, once you define the digits in all the places, hundreds, units, and tens, or how much of a digit it is, then you have to always find for two numbers. One is the 3-digit number, and if you look at the question, they are also talking about digits are getting reversed. So let us find out what will be our 3-digit number and what will be our numbers after reversing the digits. So first, the 3-digit number would be, now as discussed earlier, the digit in the hundreds place will be multiplied by 100. So we will multiply 100 to x. The digit in the tens place, this is the tens place, will multiply it by 10. So we'll multiply 10. Let me erase this so that it doesn't come in between. Okay, I have erased them now. Let us go back to the pointer. Okay, so the digit in the hundreds place is multiplied by 100, digit in the tens place is multiplied by 10, and digits in the units place, that is y, will be multiplied by 1. So 1 into y. Now try to understand, this is the most important concept. One is, how did we get the digits in the middle place, that is tens place, and the 3-digit number, that is multiply 100 to the hundreds place, 10 to the tens place, and units place, that is ones place, will be multiplied by 1. Let us try to simplify it. 100 into x will be 100 plus, open the bracket, multiply 10 to the each and every term inside the bracket. So 10 into x will be 10x, 10 into y will be 10y, and 10 into 1 will be 10, and plus y into 1 will be y. Let us add all the like terms together. Now 100x plus 10x would be 110x. 10y plus 1y would be 11y plus 10. Now this would be a very important thing, that is, this would be my 3-digit number. Now before we look at the conditions in the sum, I will also find the number obtained by reversing the digits. Now simple, reversing the digits means you replace x with y and y with x, nothing else you do. Whenever the question is talking about reversing the digits in a 2-digit number, 3-digit number, 4-digit number, whatever digit number the sum is, what we do is simply we will exchange x and y. So 110x will become 110y, 11y will become 11x plus 10 as it is. If you want, you can repeat all these steps, which is not necessary because this will be the end product. Now let us look at the condition. Now let us look at the first condition. Now the first condition, if you look at the first statement, it says the 3-digit number is, now our 3-digit number is 110x plus 11y plus 10 is, which is means equal to 17 times 17 into, so 17 into bracket. Now the question says sum of the digits. Now try to understand sum of the digits. Whatever the digits are, we need to add them. The digit in the hundreds place is x, so we will add x. We will x plus digit in the tens place is x plus y plus 1 plus the digit in the ones place, that is 1. So the question says the 3-digit number which is this is equal to 17 times the sum of the digits, that is hundreds place plus tens place plus units place will be added, and we form an equation. Let us simplify this equation. The entire left hand side will remain as it is, 110x plus 11y plus 10. Let us add the like terms inside the bracket, is equal to 17. X plus x will give us 2x. Y plus y will give us 2y plus 1. Let us simplify it ahead. Once again, the left hand side remain as it is. Open the bracket here, multiply the term outside the bracket to each and every term inside the bracket. So 17 into 2x will give me 34x. 17 into 2y will give me 34y. 17 into 1 will give me 17. Let us put the like terms together, all the x and y terms to the left hand side and constant to the right hand side. Now 110x here plus 34x shifts to the left hand side, it becomes minus 34x, that is subtracting 34x on both sides, plus 11y as it is, plus 34y here, it shifts to the left hand side, it becomes minus 34y, is equal to 17 as it is, plus 10 shifts here, it becomes minus 10. Let us add and subtract the like terms. 110x minus 34x would be 76x plus minus rather 111y minus 34y will give me minus 23y, and 17 minus 10 would give me 7, and name it equation number 1. Simple. Now students, let us look at the second condition. Now the second condition says the new number is, the new number means, if you look at this preceding sentence, if the digits are reversed, the new number is. So they are talking about the number obtained by reversing the digits. So the number obtained by the reversing the digit is, so let us first mention the number obtained by reversing the digit, that is 110y plus 11x plus 10 is, which means equal to 198 more. That means we'll leave some space and we'll write plus 198, the old number. The old number means the original 3-digit number. That would be 110x plus 11y plus 10. Simple. Now let us simplify this equation. Let us put the like terms together. Therefore, 111x as it is, 110x comes to the left hand side, it becomes minus 110x, plus 110y as it is, plus 11y shifts here, it becomes minus 11y, plus 198 as it is, plus 10 shifts here, it becomes minus 10. It is as simple as that. I hope this. Okay, once again, there was some mistake here. 11x as it is, 110x here shifts here, minus 110x, 110y as it is, plus 11y shifts here, minus 11y. Now this plus 10 as it is first, it cannot be minus, it has to be plus 10, plus 198 as it is, and this plus 10 here shifts here, it becomes minus 10. So what you can simply do is plus 10 and minus 10 gets cancelled here. So what remains on the right hand side is just 198. Now here, let us solve it. 11 minus 110x, 11x minus 110x will give me minus 99x. 110y minus 11y will give me plus 99y is equal to 198. Now, what we'll do is we'll divide throughout by 99. What I get is minus x plus y is equal to 2 dividing throughout by 99. Now students, if you want, you can name it equation number 2 and solve it by equating coefficient method. But in such type of sums, when one equation is very basic and other equation has big coefficients, I prefer substitution method, which makes it faster. So what I'm going to do is I'll keep y as it is in the left hand side. I'll shift minus x to the right hand side, it becomes plus 2x, and we'll name it equation number 2. Now I'll solve these two equations. We'll get the values of x and y and write what is the original number, that is the 3-digit number. Let us solve it, substituting 2 in 1 using the substitution method, as I told you. Now we have two equations from the previous slide. So substituting 2 in 1, that means where we will write y is equal to 2 plus x in equation number 1. So wherever there is y, we'll write 2 plus x. Fine. So in equation number 1, so equation number 1, 76x as it is minus 23y. In the place of y, we are writing 2 plus x is equal to 7. Now, this is very important to be understood. I hope everybody understood this. Let us go ahead. 76x as it is minus 23. We'll multiply minus 23 to the 2 and minus 23 to the x inside the bracket. Minus 23 into 2 is minus 46. Minus 23 into x will be minus 23. X is equal to 7. Let us solve this equation further. So 76x minus 23x. If you subtract minus 76x and 23x minus 23x, you'll get 53x, which will be is equal to 7 minus 46 shifts this side, it becomes plus 46. So further solving is 53x as it is. 7 plus 46 will give me 53. Therefore, x will be 53 upon 53, which is 1. Now, since we have got the value of x, we also need to find the value of y to find out the 3-digit number or the original number. So we'll substitute the value of x is equal to 1, equation number 2. Equation number 2, it's right there in the top right hand side corner of your screen, which says y is equal to 2 plus x. So as simple as that. So y will be 2 plus x will give me y is equal to 2 plus x, which is 1. So y will be 3. Simple. So let us find out the 3-digit number from the previous screen. We have it. 3-digit number is 110x plus 11y plus 10. So let us substitute the value of x and y. 110x, x will be 1, 11y will be 3, and 10 as it is. So 110 into 1 is 110. 33 is 11 into 3 is 33 plus 10. 110 plus 33 plus 10 would be 153. Then you can write the required 3-digit number is 153, or if you're following the question exactly, it would be the original number is 153. So I hope this sum is clear. There are many more type of sums that we need to deal, which we will be trying and try to be regular with it. So subscribe the channel to get regular updates of the sum. And thank you so much, everybody.